Yeah, good afternoon. From 5 students. Another one coming here. Welcome back, okay? Welcome back after your weekend holiday. So now the day you're getting back to your school, getting closer and closer, right? Very fast, you know. You see, next Wednesday, you need to go back to school already. Huh? Please go back to school, don't ponting, go back to school. The school will be very safe for you, don't worry, go back to school. Okay, everyone. Okay. Your friends, your teachers, they will be very happy when they see you. But we cannot get very close. Okay? So remember now, get ready, go back to school. Now, Nicholas come in one by one. Okay? We are in the last questions on this chapter 3, electromagnetism, right? Transformer. Okay, while waiting others to come, okay, let me ask some questions. What is transformer? Ask one simple question. Transformer is what? Selena. Selena, what is transformer? Tell me what you understand about transformer, Selena. Transformer is what?
An electrical device can
do what?
Increase.
Can
It can
increase?
increase or decrease the voltage.
Yes, correct. Can increase or decrease the voltage of alternating current. This is very important. You must say alternating current. Okay, that one is transformer. Okay, my second question. For swimming, are you there?
Yes, sure.
For swimming, tell me the parts, the components of transformer. Can you name a few components of transformer? The parts of transformer. Can you tell me the names?
Primary coil.
Primary coil.
Secondary coil.
Secondary coil.
Laminated soft iron core.
Laminated soft iron core. Any more?
Input and output.
Input, output, that one is not component. Okay, there's 3 parts only. Primary coil, soft iron core, and then this secondary coil. Okay. Next question. Does perfect transformer exist? Perfect transformer exists or not? Okay. Do we have a perfect transformer? Jiu-Tong? Do we have perfect transformer? Perfect one? No perfect one. Yes, Jiu-Tong, you say no perfect, right? Can you tell me one problem faced by transformer? Just one problem. What problem is that?
Loss of energy.
Loss of energy. Because of what? What caused loss of energy?
The electron.
The electron. Name it. Got name one, I think 1, 2, 3, 4. 4 reasons. 4 reasons must remember, the main problems of transformer.
High hysteresis loss.
Correct. High hysteresis loss. Then Jiu-Tong, how to overcome it? How to overcome high hysteresis loss?
Use soft iron.
Yes, use soft iron core. Okay. All right. Next. Ngo. Ngo, are you there?
Yes.
Ngo, tell me one more.
Eddy current.
Eddy current. Good. How to overcome eddy current?
Laminated iron core.
Soft iron core. Use laminated soft iron core. Yes, very good. Okay. Next one. Tan Yun Su. One more. Tan Yun Su. One more problem is what?
Resistance of coil. Resistance of coil.
Resistance of the coil. Yes, correct. How to overcome it?
Use a thicker wire.
Use thicker wire to reduce the resistance. Okay, very good. One more. Tan Chai Liang. Tan Chai Liang. Tan Chai Liang.
Yes.
One more problem is what in transformer? Someone already mentioned resistance in the wire, hysteresis loss, eddy current, all mentioned already. Got one more. What is that?
Magnetic flux.
Yes, leakage of magnetic flux. You must say leakage, leakage of magnetic flux. How to overcome it, Thailand? Huh? How to overcome it? Huh? How to reduce the leakage of the flux?
Winding the secondary and primary coils on top of each other.
Yes, correct. Okay. Winding the primary and the secondary on top of each other. So you wind it up on top of each other now. Huh? Okay. That's very good. Okay. So I think we can continue to answer the last question now. Now you look at the questions here now. Okay, the last question I think is question 12, right? Not question number 12. Is it correct? These are all finished already. Question 11 finished. Now it's question number 12, right? This question number 12. Okay. Yeah. Look at the question, everyone. Please pay attention. Diagram show 3 circuit X, Y, Z. The output of transformer in the circuit are connected with different arrangement. So you look at there are 3 transformers here. Okay, 1, 2, 3. Okay, you look at the diagram. So this is circuit X, circuit Y, circuit Z. Okay, you see now on the left side of all same one, you see 240, 1200, 240, 1002, all same now. So on the left side, no different, the input, okay? Even the current is also same, all same one. The only difference is on the right-hand side, okay? You see the number of turns here also same, 800 turns, 800 turns, 800 turns, okay? But the output connected here different now. So this one connected in series 3 bulb. This one 3 bulb connected in parallel. This one series, but this one parallel. So the connection are different, Connection got different, so got effect one, And then this one connected all in parallel. Okay? 18 watt, 18 watt, 18 watt, all parallel. Okay? So actually now this was an SPM question, the past year question, You see the question, how they ask. And now you see what the question asks. Yeah, the first question they ask, simple calculation only, you see. Both of transformer produce same output voltage. Calculate the output voltage. They want you to find the output voltage here, here, and here. Same one. You know why? Because input voltage same, 240, 240, same. Then number of turns all same, 1002, 800, 1002, 800, 1000, all same. So the voltage output here must be the same lah. So you calculate. Okay, you want to find the output voltage here, the secondary voltage, right? So use Vs on top because you want to find Vs voltage of secondary coil. So Vs over Vp equal Ns over Np. Okay, find the voltage here, voltage of secondary coil. This one you are going to find. Primary coil voltage 240, all same, all 240. Ns secondary coil number of turn 800. Okay. And then NP 1002. Okay, then you solve here, you get 160 volt. All same now. The main over here got 160 volt, here got 160 volt, here also got. Because all same, the output all same one, 160 volt. The next, all the bulb line up with normal brightness. So all the bulb line up with normal brightness means these 3 bulbs receive 12 watt. When received the exactly what they want, right? So they will line up with normal brightness. That is the meaning. Here, normal brightness means this one receive 24, this one receive 12, this one receive 12 watt. Same lah. Or this one receive 18, 18, 18. Then it will line up with normal brightness. Now the question. The current 0.25 all same, 1, 2 all same, flowing in the primary coil. Calculate the input power. Okay, power VI. You see? Power, you take voltage times current. Voltage in the primary 240, current 0.25. So you get 60 watt. So the power in the primary coil is 60 watt. Okay, input power 60 watt, you know. Got the answer already, huh? Okay, 60 watt means here lah. The power here, VI. VI, you take voltage times current. Voltage, current, you get the power all same. Okay, 60 watt. But now I want to tell you, everyone input 60 watt, 60 watt. The power is 60 watt, right? But the output now, you see output, you see like this, you know. The output power, not the voltage, is power, is watt. What you see like this, you know, you don't care is series or is parallel like this. You don't care. You just add up everything. Like this one, you add up everything, so become 36 watt. So input 60, come out here, left 36 watt only. There's a lot of power loss, no good. This one input 60 watt, but output here 24 plus 12 plus 12, so it's 48, slightly better lah. Power go in, input power 60, output power is 48, not too bad now. Okay, this one, input here 60 watt, output 18, 18, 18, add up, You don't care one, or parallel or series also, you add up one. Power is like that one, not the voltage, So when you add up, you get 54. I think this is the best lah. Because input 60 watt, your output here is, you add up, is 54. So it's quite good, you know, okay? Yeah, okay, now we answer the question. No? The answer here now for X, the power output 36. For Y, the output power 48. For Z, output power 54. So this is the best, okay? The best. The highest lah. Input 60, output 54. So good lah, because you only lost 6 watt only. So it's very good. This Eric, why now? Why now only come in? I think he went to toilet, Eric Lim. Yeah. So far understand, Okay, now next. Which one is the best? So the answer is Z block, right? But I do want to tell you the answer lah. Why Z is the best then? How to give answer? Why Z is the best? Xia Xing Yin. Why Z is the best? Xia, give a reason. Why Z is the best? Why then? Why the answer here Z is the best? Why? Xia?
Less power loss.
Less power loss, you can say that. Because input 60, output 54, right? So loss will be 6, so it's the best lah. Yes, correct the answer. So the answer, you write in a proper sentence, so you write like this. It has the highest output power. The output power is the highest, right? 54, you see here, 54, right? The highest, 54. Therefore, its efficiency is the highest. When the output power is high, means the efficiency is high, you know. Okay, very efficient now means this transformer is efficient. Okay, right? Highest output power, therefore efficiency is the highest, the most efficient now. So transformer Z is the best, Okay, so finish. Harry Young, how are you?
Yes.
Yes, how?
Good lah.
Got copy answer or not?
Got.
Got, Okay, good. So we have finished
So.
what?
After we school reopen, then we wear school uniform or koku. What?
Only wear school uniform.
Okay, no more koku. Okay, good.
No koku, no PJ shirt.
Okay, go. Okay.
No.
PJ
Only
shirt
school uniform. Only wear school uniform.
PJ shirt better lah. Okay.
Yeah. All right. So finish. So we still have one more lesson. This chapter 3 got 5 lessons. We finished 1, 2, 3, 4. This one is 4. Got one more lesson 5. Okay. Okay. So shall we move on? You want to? Shall we move on now? You want?
Can.
Then you want. Okay. This re-end. So far, transformer lesson 4. Understand?
Yes, sir.
You understand? Where is your good friend? Hui Xin here or not? I didn't see her name. No, Hui Xin. Hui Xin not here. No lah, Hui Xin not here. She pointing class, I think. Hui Xin. Okay. You have the lesson 5 paper with you, right? I share in the group where you want, no? Okay, lesson 5 paper. Okay, now we look at lesson 5. Lesson 5 is also very important one. Don't play, you all. Lesson 5 paper. Here. This one. Got a paper. Understanding the generation and transmissions of electricity. Okay. Last parts of chapter 3. Yeah. Okay, in this lesson 5, right, you see the title, you know already. You only study 2 important things, One is generations. Generation means to produce electric. How to produce electricity. You must understand, the electricity you are using every day, right? How the government produce it. Or the company, Tenaga Nasional, how the Tenaga Nasional produce electricity for the whole country. Another one is transmissions of electricity. Okay, transmission means to transfer, Why then? Okay, let me tell you lah. The current we use in Malacca, for example, right? Actually now, this electric we use in Malacca not generated in Malacca one, It can be generated all the way from Terengganu, from Pahang. The generator, the power station in Terengganu, in Pahang, they generate the current over there, in Canoe Lake, in Pahang. And then in Cameron Highland got one. Okay. So this generator that generate the electricity, right? They need to transfer it, need to send all the way from Terengganu to Malacca to Johor. So this is a big process, very important one. I'm sure you have seen it, right? So you can see near the highway, when you train the highway, you look at the jungle, got the cable, isn't it? The high cable, right? That cable means it's a cable transferring the electricity one throughout the whole country. Okay? Whole country one, it can be generated from Terengganu, then sent to Pulau Pinang. Okay? Sent to Johor, right? In Malacca, very sad, we don't have, no power station, big one. We got one very small power station in Malacca, very small one. This power station only can generate current for Kelebang only. Other side like Jasin, Alogajian, okay, Malacca Town cannot use the electricity. Not enough because Malacca one, the power station is very, very small. Okay. Do you know in Malacca where is the power station? You want to? Where is it? You want to? You want? 医生人没有出过门的，不懂的。Where is the power station of Malacca, Mafuza? You know or not? Where is the power station in Malacca? Generate electricity in Malacca one? Hah? Dekat mana tu?
I don't know.
You don't know ah. Okay, actually it's very near to our place, you know. Malacca got one very small power station which is near Tanjung Keling. Tanjung Keling got one. You don't believe why you go to Tanjung Keling, you can see the power station. Okay, Tanjung Keling got one. But that one is a small power station because Malacca here we don't have mountain. You cannot have water dam. Water dam, so the water flow out, then to push the motor. You know, this one we don't have in Malacca. Malacca got water dam lah. In Durian Tunggal got water dam, right? But this water dam is just to store water for daily use only. Cannot use for generating current one. Malacca water dam very low one. Okay. Yeah. Okay. Now we start. First one is generation. Generation means how to produce electricity. Okay, please highlight. Yeah, 1, 2, 3, 4, 5. 5 different methods to generate current, you know. Highlight now. First one is using the store energy. Okay, store energy, for example, like fossil fuel. Fossil fuel means like diesel, like petrol, right? The fossil fuel, the diesel, petrol, this one we get from the soil underground one. That one is considered store energy. Okay, and nuclear, nuclear. This is the latest one, nuclear energy, and biomass. What is biomass? By the way, biomass is what? Okay, biomass means is a heat energy produced by waste product, like rubbish, waste product. Okay, you can produce heat one, you know, so you call biomass. Okay, so first one, remember that store energy, use petrol, use fossil, okay, use diesel to run the engine. Like Malacca one is here lah. Malacca one is store energy. Malacca one, the one is Tanjung Keling, use natural gas. Use the natural gas supplied by Petronas. Use a gas to run the motor one, run the generator. Okay. So Malacca using this method. Okay. Second one, gravitational potential energy. This one is hydroelectric. This is the best. Use of water power. When the water flow down from the top, from the mountain, the water flow down. So the water energy can push the generator to turn. Okay. This is called gravitational potential energy. This is the best lah. Using water hydro. Why is gravitational potential? Because the water store at a high place, right? So when allow the water to flow down, so the water carry potential energy. Understand? When the water flow down, so it push the motor to rotate. Yeah, the generator. The third, kinetic energy, wind. Use a wind turbine. Okay, turbine wind. The windmill, you know or not? Okay, when the wind blow, right, so the turbine will turn. Okay, when the wind blow, you can see the fan turning, right? The one can generate electricity lah. Kinetic energy, the one use kinetic energy. In Malacca also we have this windmill, you know. You know where is the windmill of Malacca? Windmills of Malacca doesn't use to generate electricity one. It's used for people to go there take pictures one. And Geothermal. You know where is a windmill or not? You know where is a windmill or not?
Don't know.
Where is a windmill in Malacca? Not for generate electricity one. Okay. Okay, number 4, solar energy. Energy come from the sun. Use the sun Okay, sun to generate electricity. Okay, for now in Malaysia, right, we use the sun energy to boil water only. Okay. We since say her English tuition suddenly change. Oh, okay, understand. Okay. Okay, Rianne, thank you. All right. And last, chemical energy. Chemical means I use a chemical reaction. This one used in the battery. Okay. Transform direct at chemical electrical energy. For example, in a car battery, the battery, dry cell you buy from the shop, right? That one is called, okay, remember now, store energy, gravitational potential energy, kinetic energy, solar energy, chemical energy. These are the 5 sources to generate electricity. Okay, remember the 5, 1, 2, 3, 4, 5. Okay, now sources of energy can be divided in 2 categories. Okay, just now the 5 sources of energy, right? Now can divide into 2, 2 groups. So please highlight. First one is non-renewable sources. Non-renewable means cannot renew one, can finish one. Use 10 years, 100 years, 500 years, so it finish, no more. So that one is non-renewable. Okay, example, fossil fuel lah. Fossil fuel means, for example, like petrol, natural gas, diesel, all these are fossil fuel, come from the ground one, can finish. You must know, current stock of petroleum, the current stock of petroleum in the world, right, in our world now, can only last for another 50 years now. Now you are 17 years or 18, 17 years, right? Another 50 years, you are 67 years, right? So when you are 67 years old, no more petrol already, no more diesel, no more natural gas. Finish already, the current stock of petroleum on Earth can be finished in 50 years' time. So it's very sad, So when you are 67 years old, you want when you are 67 and no more petrol already. You want you hear it or not? 到67岁没有汽油了，yeah. Okay. Nuclear fuel, nuclear also the same. But I tell you, fossil fuels we use it so much now, but nuclear, no, we didn't use. For example, in the world, right, only a few countries they know the technology using nuclear energy. Okay, example like in United States, Russia, China, these few countries they have the technology use nuclear energy to produce current. Our Malaysia don't have, not even a small one, a single one also don't have, no nuclear energy in Malaysia. Very sad, no. So it's in your hand now. You must study hard, learn more to develop our country, okay? So that our country can use a nuclear fuel. Because you know why, other countries are using the nuclear. We are not using that. Then one day finish already, so we don't have a chance, even the chance to use. No chance to use also, right? If you don't use it now. Okay, in your chapter 5, you will learn nuclear energy, okay? All right, the second one is renewable one. This one cannot finish one. Can be renewed means cannot finish one. This one is good but very sad, no. This one are not being widely used. We use the most one this non-renewable one, okay, especially fossil fuel. Okay. The one renewable one cannot finish one. Okay, we only use hydropower. Hydropower means water. Use water to push the turbine to rotate. They want use water. Now water cannot finish one. Because water you use already, the water go up to the sky, then it come down again. Water cannot finish one. Okay? Hydropower. Solar energy, the sunlight also cannot finish. So you have to use, but hard to use it now. Biomass, the rubbish. Actually, the rubbish can be used to produce current, produce natural gas, but our country never use. Okay. Wind power, wind power also good. When the wind comes, we can use the wind to blow the windmill to rotate. When the windmill rotating, I can produce current, right? Very good, but we don't use it. Geothermal energy. What is geothermal? Okay. Geothermal means the heat energy underground. Actually, when you take deep inside underground, it's very hot one, You know the volcano, right? Certain place they have hot spring, hot spring, the water come out very hot one, you know. It show them underground is hot. So if one day we can use a heat energy underground, right, to generate current, then you can save a lot of money. Okay, the one is geothermal energy. And wave energy, the sea wave. Actually, we can use a sea wave, you know. When a sea wave come, so when the water come, the water can use to push the turbine. High technology to make it lah. Okay, one country very successful using wave energy is Ireland. Ireland, no. Ireland now they have a lot of these power station, right, built on the sea one. So they use the seawater. The seawater, the wave come in, go out, come in, go out, right? So the seawater actually can turn the turbine. Okay. Yeah. Ocean thermal energy, same lah. This one under the sea also got heat one, you know. Ocean thermal energy. And last, tidal energy. Tidal means high tide, low tide. 涨潮, 退潮, 知道吗? Okay. Tidal. Okay. Tidal energy and wave are slightly different, you know. Wave means a water wave. Non-stop one water wave. Tidal means when high tide, air pasang, when the high tide happen, the water come in, so the gate open, so the water will be stored in a big tank. Then when low tide, so the water release, then water flow back. When the water flow out, water power can use to rotate the turbine. So that is called tidal energy. Okay, so this one you have to remember, you know. It does come out one, I tell you, renewable, non-renewable, remember, okay? Okay, now look at the first one, thermal power station. Okay. This one I explain now, you listen now. Thermal, the name thermal means heat. We use a heat to produce electric. So this is called thermal power station. Okay, you don't understand what is that, right? Okay, come, let me explain, you listen carefully. You must be able to listen, you know. Okay, more patient, listen. Okay, you look at here. This is hot water vapor. This is a hot waste gas. Okay. Actually, the diagram not clear. It should be like this. Pipe is here. Connect to here one. Okay. Okay. This is a big container of water, right? So water is here. So this water will be pumped. You see, there's a pump, right? Pump the water here. Water go in now, right? So this is a furnace. Furnace means is a boiler, you know, to boil water one. So the water here you use to boil water lah. So the hot water okay, now I tell you how to boil the water. We use petrol to burn. Use a natural gas to burn, right? In Malacca, it's like that. Tanjung Keling one use petrol, use natural gas to burn, to boil the water. The boiler, you know, is to boil water. Understand? Okay, used to boil water, right? So the water is very, very hot. So it will heat up this gas inside. Okay, so here because here is a water pipe, you know, when the water is very hot, right? So the water inside becomes steam. This piping system also got water, you know, because this water is too hot, burn, right? So we'll change this water to become steam already. So the steam will be flow over here. Okay, the steam is in high pressure steam, you know, high pressure. Here low pressure, up here high pressure. You see, high pressure steam at 900 degrees. So basically, use a natural gas, use a petrol to boil the water, heat up water, boiler heat up water to change this water inside the pipe into steam. The water become too hot already. So this water too hot, it changes into steam. Okay, 900 degrees, you know. So the steam is in high pressure. So when the steam release, it shoot out, right? So it will rotate the turbine. So this turbine will rotate, it will turn, then rotor will turn to generate the current here. So this is a generator here. When the steam release, so this thing will turn the turbine. So this thing turning, so the motor running already, so can generate electricity. And then electricity sent to transformer to step up the voltage to this high cable. So it will send from here, from Terengganu, all the way sent to Malacca. Okay, all the way, very, very far. Okay, from Terengganu sent to Malacca, very far, you know. Okay. Yeah, this is thermal. Thermal means use of heat. Heat produced by burnings of petrol, burnings of natural gas. The water heat up, so it will become steam. Use of steam. Steam that release is very high pressure, so it will rotate the turbine to run the generator. Generator turning, right? So it can produce current. Okay, that's the way. Yeah. Fossil fuels such as coal, petroleum, natural gas, or even uranium. Uranium is nuclear. Used in thermal power station. Heat energy produced by burning coal or oil in the furnace. Here, burn it. Form of fission of uranium. This is chapter 5 you learn. Water absorb the heat energy in the boiler. Okay, water absorb the heat energy in the boiler and heat exchanger and turn into steam. This one becomes steam, high pressure. Okay, the high pressure steam convert heat energy into mechanical energy and turn the turbine. Generator convert the mechanical energy into electric. Okay, but it's very sad. Efficiency very low, 30 to 35% only. 30 to 35% of energy stored fuel transform into electric energy. It's very sad, Okay, only 30 to 35% of the energy can change into electric. Okay, the disadvantage, this method why no good? This one is in Malacca one, thermal power station. Okay, I tell you how to remember. Thermal power station means use petroleum, petrol, diesel, coal to boil the water. The boil water hot already, so you change the water into steam to turn the turbine. The one is called thermal power station. Okay, no good one. You see, got a lot of disadvantages. Also, you must know, even boring, you have to know now. Okay, air pollutant can pollute. Okay, because burnings of petrol, burnings of natural gas, burnings of the coal, you can produce pollutant to pollute the air. Okay, just highlight title. This one no good. Air pollutant. Next, it can cause acid rain. You know what is that, right? So it produces types of gas, right? Get the gas sulfur dioxide gas, nitrogen oxide go into the sky mixed with the water, so it become acid. So it come down. So acid rain, no good. Greenhouse effect, also no good. You know what is greenhouse effect? What? Greenhouse effect means the weather become very, very hot. The sunlight when come in here, the sunlight cannot go up because it's blocked already. So all the sunlight got trapped here, so become very hot. Greenhouse effect. Now actually we are having greenhouse effect here, very hot. Okay, and then it's non-renewable. Petrol, natural gas are non-renewable. Can finish one. Expensive. Okay, harmful effect of radioactive. And one more is the smell is very bad. Smoke, right? No good. Okay. And the advantages, the good things about these advantages is what? So those here remember all these are disadvantages. Okay, now we look at a few advantages. So only 3 here. Advantages. First is can develop a new town. Okay. I take example like Canoe Lake in Terengganu. You know the lake or not? Actually, the canoe lakes is built for hydroelectric one, you know. Okay, the canoe lake is the largest man-made lake in Malaysia. Okay, canoe lake. Once a lake was built already, right? So the surrounding area now, because you have a power station, a lot of people need to work there. So they build a lot of houses, and then slowly they build up a house, a town, commandment, okay, a big town. So you can develop a new town lah, okay, when using this kind of power station okay, can recycle the waste matter, okay, biomass. Okay, for example, use coal, use a petroleum, use a petrol to burn got side product, right? The one can be recycled lah. And use amount of radioactive is small amount of radioactive. Using radioactive, you need a little bit only. So the advantage, okay lah. So remember, first one is thermal power station. Remember thermal power station. In Malaysia, it's still very common, you know, we use many of them. In Johor got 2, Malacca got 1, okay? And the next one is hydropower station. This one. Actually, this one is the best, you know, hydropower station. Okay, very simple. You see here, how this thing work. The generator is here, you see? So how to rotate the turbine? Okay, you keep the water here, the water store at the dam. You store the water at the dam, you know. A few rivers of water, like all the water kept here. The water powerful now, the water release, come down. So this powerful water, right, will carry the potential energy, right, and make the turbine to turn to become kinetic energy. And when this turbine is turning, right, it can produce electricity. Very simple, you know. Who asked question? So the radioactive is used for what? Okay. Radioactive in chapter 5 you learn in detail. Okay, now I see you asked already. So I explain a little bit for you. Okay, come look at here. The radioactive you say radioactive can be used here, you know. Okay, listen. Besides using petrol, natural gas to boil the water, right? To change the water into steam, we can use a nuclear energy, you know. Nuclear energy means a nuclear bomb. Nuclear bomb exploded. When the nuclear energy explodes, right, it will release a lot of energy. So this energy, same lah, you can put it here. Use the energy to boil the water. Can you understand? Nuclear energy like explosions of nuclear bomb, you know. So it produces a lot of energy. So this energy can use to boil water. Okay. So that's how we use a nuclear lah. Understand already? Okay, okay, can we? All right. Now we go back here. Yeah, hydropower. So this matter you understand already, you know, how to use the water. That's why Malacca cannot. Malacca don't have mountain, you know. The water must store at a very high ground, high place. When you release the water, the water come down only got power one. So sad Malacca during Tungkan dam is not high, you know. So you release the water, no power, cannot use to generate. Okay, only like area in Terengganu in Pahang gap. So the water can store in a high place, right? When you release the water come down, the energy potential change to kinetic. So kinetic will rotate the turbine. When this turbine is rotating, it will produce current. This is a generator. So the current can send to the whole country. Okay? So very big one. Okay, this one actually is the best, you know, it can last many, many years. Okay, no pollution, no problem, because no smoke come out one. Only water, water make this thing turn only, so no smoke, no pollution. So it's the best. Okay, and some more this water you store the water here it can become a tourist how to say that, tourist attraction, you know, a lot of people will go there, see the place. For example, like Canoe Lake. Canoe Lake got a lot of people go there now to play one, you know, to fish, fishing, swim, and so much can do in the lake, right? And then the lake is very beautiful. Okay, all right. In hydro station, there's no need heat steam, no need heat at all. We use the water to push on it. Water collected in a high reservoir here, water dam, and possesses high gravitational potential energy. When the water flow through the pipe, its potential changes to kinetic energy. Kinetic energy of water changes to electrical energy when the water turns the plates of the turbine. Okay, you turn that. Okay. The disadvantage. Why this one? Just now I say so good. Now got disadvantage. What are the disadvantages? Disturb the equilibrium of ecosystem. Yes. Large area of forest land has to be destroyed to grow flora and fauna. So, example, I take one example in Canoe Lake. You know how big is a Canoe Lake or not? The Canoe Lake is 3 Singapore, you know, the size like 3 Singapore island. You can put inside the lake. This Canoe Lake is not natural one, it's man-made one, you know. You know how they build the Canoe Lake? They channel the river water in Terengganu, got 5 to 6 river water. All the river water, the water flow into that area. Then they build the wall, you know, to capture the water. So 1 year, 2 years, 3 years, 4 years, then the water level getting higher. So when the water level getting higher and higher, so it will flood more area. So a lot of people have to shift. Okay, and animals, the jungle, all the tree all die already. Animals also die because the water Because when they build a wall to cover up the place, right, to capture the water, very big area one, you know. So all the trees, animals will die because slowly the water come in, right? The water may take a few years to fully fill up the place one because the place is very big. They only build a wall only, you know. You see here, only the wall. This wall cover the size of 3 Singapore in Canoe Lake. This wall cover the Singapore, 3 sides of Singapore, you know. Then it takes 5 years for the water to fully fill up. 5 years of the river water, 5 years of flow inside there, then only fill up the place. Then full already. Once the water full, then only they start release the water. Water must be full. Then only they start release the water, then start to generate electricity. It's a long time when, you know. Okay, so it destroy the jungle, kill the animals, and even people stay in the kampung one also have to shift. Okay, yeah. Second, displaces local population. I told you just now, right? When they want to build the dam, right? There are many kampung in the Terengganu, right? They ask the kampung people to shift. They give you money, give you a little bit of money, ask you to shift. Then you cannot stay in this kampung already. They tell you this kampung in 3 months' time, the water will be cover up the whole kampung. So all the people have to shift. So they give you about 10,000 ringgit, as if you go and find a house yourself. Okay? Yeah. That one is called displaces local population. Okay? Highly cost. You need a lot of money to build this dam one, you know. The dam is very, very big. Of course, you need a lot of money to build. And also the generator, right? Okay. Costly lah. But I think for me, it's worth to spend the money, okay? Because hydropower station can last long time. Once this thing started to work already, it will last very, very long, last 100 years, 200 years. Okay? Because the water can non-stop flowing out non-stop. So this generator non-stop moving produce current non-stop, right? Very good. Okay. Advantage, clean and does not emit pollutant. This is good. I told you just now, no pollution. Very good, very clean. Okay. And then it's renewable. Renewable means cannot finish. The water cannot finish one. Okay. Can develop a recreation area. Example, Kenyulik Law. Kenyulik become a famous tourist spot, okay, in Malaysia. Can develop a recreation area. Yeah. And last, can control flood. Why they say can control flood? That because they channel the river water to the area, fully fill up the dam, right? They can see one, when the dam is full, the water full already, they can release the water. So they can release the water, come out, right? So you can control the flood now. Flood, no flood problem already in Terengganu. Only in Kelantan got, okay? Yeah. Next, solar energy. I remember. Remember now. First one, thermal power station. Second one is hydropower station. Third, solar, use the sunlight. I use the sunlight one. I think I don't need to explain already. You need the solar furnace to absorb the sunlight. Okay, you see like this. Absorb the sunlight. This thing, absorb sunlight, then focus the sunlight here to heat up the water. This, when you focus the sunlight here, it become very hot. You can heat up the water, okay? When heat up water, then you see this diagram. When the water heat up already, you can use to boil water here. Now this one is sunlight absorb. This is absorbing the sunlight, so this thing become hot, right? So the heat sent here to boil water. You see or not? No? The heat come here to boil up this water. So normally this solar energy boiler, right? It means to heat up water for shower only, not for cooking one, not for drinking, understand? No, before shower, you take shower, hot water, you can use this one, okay? Okay. Then solar cell. Solar cell absorb the sunlight, direct turns into electric. So we call it solar cell, okay? Disadvantage, require large area to collect the sun ray. Yes, correct. To collect enough sunlight to produce electric, I tell you, the panel will be very, very big, okay? So you need to have a very big area, very big size one to collect the sunlight, so very troublesome, okay? Next, efficiency of conversion is quite low, 5% only, you see. Sunlight, you collect the sunlight to generate electric, only 5%. No good, okay? Intensity of sunlight collected is not consistent. Sometimes got light, sometimes no light, so not consistent, right? Depends on the weather, so no good lah. Advantage, green does not pollute, right? Sunlight, no pollution, so good. And renewable, means the sunlight cannot finish one. And also it's free, right? Okay, number 4, wind energy. This one using the wind, right? Wind rotate the turbines of the windmill. So actually this is a generator here now. On top here is a generator. Okay. So when wind blow, right? So this thing will rotate. So the generator started lah. So it will generate current. So current come down, all the current send to a place lah. Okay, wind energy. Malaysia not even single one. No, I don't know why no Malaysia. Malaysia, the places in Malaysia are all no wind one, so cannot use. Then you must find a place you can have constantly the wind come, then we can use okay. This one I think okay lah. Disadvantage, large area, you need very big area. The speed of rotation is not consistent. Sometimes fast, sometimes slow, so no good lah. Produces noise. When this thing over here, when it turn, very noisy. Okay. Advantages, clean, no pollution. Renewable, the wind never finish. then it's free. Correct not? Yeah. This one wave energy. I use this diagram to explain wave energy. You see, when the water wave come, right, then we'll rotate the things. When the wave push this thing, it go up, come down, go up, come down. So it will rotate. So this thing will rotate one, You see, when the water push, so it turn over here. So when the water go down, so it turn. So keep turning. Now you can produce current, okay? Using the wave energy, make this thing the generator to rotate. Wave energy, okay? And I look at a little bit here. Disadvantage and advantages. Can you read yourself? High cost building. You want to build a power station on the sea, it's very costly, okay? And then it's very vulnerable and difficult to defend because when wind, the wave can be very strong. Very strong. Sometimes when a strong wave come, it can destroy the whole thing. And then some more is salt water, right? Salt water will cause rusting very fast. Okay. And the advantages: clean, no pollution, renewable, and then free. Correct not? Okay. All right. We have finished first part now. Okay. Now question time. Okay. I let you rest 2 minutes first. When drink water, you can drink water.
5 minutes, 5 minutes.
Drink water, you don't need 5 minutes. Harry Yong. Yeah. Okay, now, the methods of generating current. What are the methods? First one you learned was thermal power station. First one, right? Second one is what? Chan Ching-yi. Method to generate current. First one is thermal power station. Second one, Chan Ching-yi.
Hydroelectric power station.
Hydroelectric power station using water, right? Third, Kirtana. Third method, Kirtana Murti.
Solar energy.
Huh?
Solar energy.
Solar energy using the sunlight. Yes, solar energy. Next one, Apple. Apple.
Yes, teacher.
Apple, what is that?
Wave energy.
Wave energy. Yes, correct. Wave. Next, Zhuang. Zhuang Si-en.
Yes, sir.
Next method is what?
Wind energy.
Wind energy. Use of wind, right? And any more? Liao Jingning. Any more method or not? Liao. Hey, Liao Jingning. Liao, any more?
Solar energy.
Solar, I think someone mentioned already. Never mind. I think you all know what is. Okay, so we have finished one part already. Now we move on to the next one, which is, I can say is more important. Transmission is more important. Okay. Transmission. Okay. Don't look at here first. Let me explain to you first. Transmission is like this one, I use this diagram, okay? You must understand this diagram first, okay? Okay, actually, this diagram is already covered the whole country one, okay? Okay, now follow here. I go one by one slowly. You all listen. This is a power station. Power station. Start from the power station. This power station, we can use hydropower, use thermal power, solar power, anything to generate current. You see the power station producing 25 kilowatt. Only 25 kilowatt, 25,000 watt, right? The wattage. This wattage cannot be used directly from the power station, right? Nobody use the current or the wattage direct from the power station, one cannot. So what you see the whole diagram is like, when power station generate 25 kilowatt, right? First place is sent to a transformer, you see. Hey, the whole diagram, you better careful, listen more. The power station generated 25 kilowatt, then sent to a transformer. This transformer will step up, 25 kilowatt to 2075 or 400 kilowatt. You see, step up so high, Then from here, 25 kilo is step up until 400 kilowatt. 400 kilowatt, the wattage become very high. That means this transformer is the most important. It's very big one, huge transformer. Because this transformer able to step up 25,000 to 400,000. Okay, now one question. Why need to step up so high? Okay, the reason is like this. As when you study transformer, right, when I want to ask you, when the watts in the transformer got input output, right? When you step up the wattage, when the wattage become high, what happened to the current? Remember or not? In the transformer, when you step up voltage, what happened to the current? No one answer me.
Decrease.
Yes, current decreases. Remember, the purpose is to decrease the current. You step up so high voltage, the reason is you want to make the current here very, very small. In the cable here, when you see in the jungle, in the highway, right, you can see this cable. Actually, this cable, the voltage is very high, but the current is very, very, very small. Why the current to be very small? The reason is when the current is small, right? So the power loss will become minimum because power loss formula is what is here. I tell you lah. Loss in the power P, right? The formula is I square R. Then these are the two things will cause the power to loss. First is the current. Second one is the resistance. So you see now, from Terengganu, you want to send to Malacca all the way, right? So you cannot afford to have energy loss here, power loss cannot. You don't want the power to loss. So what you must do is step up the voltage, make sure this current becomes very small. When the current I is small, right? So the power loss also becomes small. That is what we want. Current here very small. The current small, the purpose is to reduce the power loss because power loss is directly proportional to square of current and directly proportional to the resistance. Okay, now got two things here to do. The engineer must do one, Make this high cable current small. So how to make the current small? Use a transformer to step up the wattage. Voltage very high already, the current become very, very small. Then power loss minimized. And one more is how to reduce the resistance. Here. You want to reduce the resistance, right? So first you must use a low resistance material, right? Low resistance material, for example, copper, right? But copper wire is too heavy, very expensive. You want to hang it up here very tall, very far, Use copper wire, very heavy, very difficult to hang, cannot. Some more copper wire, copper is very expensive, A lot of people will go and steal the copper wire, go and sell. Copper is very expensive one, I tell you. Okay. And then what they do to reduce the resistance is they use low resistance material. They don't use copper, but they compromise a little bit. They use aluminum. Because aluminum is light, very light. If they hang here, hang very high also doesn't matter because aluminum not heavy. Aluminum is, the resistance is a little bit higher than copper lah, but doesn't matter lah. But aluminum is very light. This one use an aluminum cable. Okay, remember that, huh? Wait. Aluminum cable we choose because aluminum is light, not because of resistance low, you know. Resistance low actually copper better. Okay. Okay, so two method. Another one is to make this wire very thick. You know what? Thick wire resistance low, correct not? Okay. So remember this wire must be very thick. The size of this wire can be the size of your head, you know. See from far, you see the cable very small. Actually, when you go near and see, this cable very big one, you know, like your head, the size. The cable is very big, made from aluminum. Hang here, no, but never mind because it's very light. And the worker also easy to carry lah. Okay, know the reason already, Okay, now step up again when sent to a place near to a town already, right? For example, like from Terengganu, go near to, let's say, the place near Terengganu, let's say Kuantan, near Kuantan, a big town, right? Then need to use another transformer to step down to 132. From 400, you know, it stepped down to 132. Okay, this is a transformer again, no? Because too high voltage cannot use one. So I have to step down to 132 and then further step down to 33,000 for heavy industry area. Because industry area need higher voltage, you know. So you see now, wait, only this one step up to 4,400. Then after that step down 130. Still cannot be used, too high. Then step down to 33,000. First place is for big factory, heavy industry, use 33,000. So far in Malacca, only one, you know, only one factory considered heavy industry. You know what factory in Malacca? Which factory in Malacca is considered heavy industry? Che, do you know or not? Che, which factory in Malacca is considered heavy industry? Factory near highway. I tell you, near highway. You know why? Because all these cables are for near the highway one. So this factory built near the highway. You know where is the factory? Which factory in Malacca near the highway one?
I don't know.
You don't know, Apple, do you know or not?
I don't know.
You don't know. Okay. Liao Xingxiang, you know what factory near the highway?
No.
No. I give you a little bit tips. You listen carefully. It's near Simpang 4. You know Simpang 4 or not? You go Alokaja, when you exit to the highway from Alokaja, you pass through Simpang 4, right? Near Simpang 4, before you go up to the highway, right? You can see on the right side there is a big factory. What factory is that? Anyone knows or not?
Power.
What factory? Honda. Yes, correct. Honda car. Yes, in Malacca, the biggest industry is Honda factory. Whole Malaysia Honda car all example in Simpang 4. That factory is considered heavy industry. So using 33,000 watt one, only one factory, no. The other factory or small one, Batu Berendam, Aikro, the one is not heavy industry. Okay. So you see here 33,000 for heavy industry. Next, Step down again to 11,000. Use another transformer to step down to 11,000. This one for light industry. Light industry, this one like Batu Perendam, Malim Jaya, Batu Perendam, all these are considered light industry. So you step down to 11,000 more, right? Then next is another transformer, step down to 415. Okay, 415 watt is for school, for big shopping center, for hotel, for hospital, for government office. They use big wattage one, 415 watt. Okay, from 11,000 step down again, use another transformer to 415 watt. Okay, for shopping center lah, hospital lah, all these And last, then only 240 watt. This one for us lah, for housing area. Understand? So you see the whole system here. Start from the power station. Only one transformer is step up. Only the first one step up. 400. The rest all step down. 132. Step down to 33,000 for heavy industry. Step down again to 11,000 for light industry. Step down again to 415 for hospital, shopping center, and so on. And last, step down to 240 for housing area for us. Okay, you can see the whole system, how the system works or not. It's very complicated system, That's why Tenaga Nasional charges us so much, because Tenaga Nasional to build out all these things, all these transformer need a lot of money, Step up transformer, step down, all these transformer are very big one. Okay, it's very expensive. And then someone need to maintain that. That's why when the Tenaga Nasional charge you 400, 500 per month, so you don't jump. If you jump, don't use electric. Apple, understand?
Yes, teacher.
So don't jump.
Yes.
They spend a lot of money to develop all these things, Actually, Tenaga Nasional. Okay, now you see, here only one power station, Do you think one power station can supply electric to the whole country? Can or not? Like Huakai?
No.
No, cannot. Definitely cannot. If whole country only rely on one power station, very dangerous now. If this time power station got problem, then the whole country no electric can die now. So there's a system connecting all the power station in the country. We call it National Grid Network. So all the power stations from Terengganu, Pahang, Johor, Malacca, Kedah, all these power stations, they join up to form a network. So they call it network, National Grid Network. So meaning it's like this, all the power stations have to send all the generated power to this cable. This is called centralized cable. All the power stations in the whole country, have to send to here. Step up to 400,000, they send to here. All the country, the whole country all join up one. Okay, they had to use a cable, underground cable, or from the power station, use a transformer, step up or send to here. Then here got one central control center, which is located in a top secret place in Malaysia. They don't let you know one, There's a control center to manage this high cable. That control station is very, very isolated inside. Nobody knows one. No road to the place one. You know why they don't build road? They don't want let people to go there, go to the place. You know why? That place will become a top secret. You know why? If not, people want to conquer Malaysia, right? Let's say that one day America want to attack Malaysia, for example. America, they are very smart one. They want to conquer Malaysia. Very simple. Send a bomb to destroy the center controlling the electricity of the whole country. Done. One small bomb only destroy the place, your whole country black out, then very easy to conquer you already. That's why this control center they will never let anybody know where is the place. Even the America, the Google satellite also cannot find the place. They don't let you know. Only Tenaga Nasional, only the Prime Minister knows, okay, know where's the place, okay? It's a central control system now. It's controlling here one. Okay. So okay, so network means it's a network connecting all the power station in the country in one long cable. So the rest all do the same lah. Okay. Okay. Okay, now go back to the starting point there. Okay, now you already know a little bit already. Now come back here. Actually, I already explained to you just now. Okay. Okay. Transmission of electricity. Okay, you start here. The major problem to transmit electrical energy from power station to the user is, okay, highlight power loss. I told you just now, right? Power loss in the cable. Power loss in the cable as heat. This is a main problem faced by Tenaga Nasional. In the cable got power loss. Okay, so you see the formula. Power loss formula in the cable is P equal to I square R. The current cause power loss. The resistance cause power loss. Right? Energy loss. The formula is I square RT. You multiply T, so you become energy loss. This one is power loss. PT, power multiply time, so you get energy. So this energy loss, I square RT. Okay, I square R. Okay, so you see yourself here. Power loss is P, I is the current, R is the resistance. Okay, now, the rest I think you don't need to know. Okay, now, here. Can you all see everything or not? Okay, reducing power loss in transmission line. This one highlight, this is very, I can tell you this part showed us in the SPM. Using thick cable with large cross-section area to reduce the resistance because power loss directly proportional to the resistance. Highlight, I told you aluminum, right? Aluminum alloys are used because they are cheaper, aluminum cheaper and then lighter than copper. Not to say aluminum better than copper, no. It's because aluminum cheap, because the cable so thick, right? So long from Terengganu go to whole country, it's very, very long, very costly. If we use a copper one, it's very expensive, okay? So use aluminum, and because aluminum cheaper and then it's light, okay? Second one, reduce the current. How to reduce the current? Transmitter at high voltage, I told you just now, right? Use a transformer, step up to 400 watt, increase the voltage to decrease the current. When the current is small, because power loss is directly proportional to the square of current. When current is small, you step up voltage, current small. Current inversely proportional to the voltage, right? When current small, the power loss becomes smaller. Okay, understand? So remember these 2 points and all. Okay. How to reduce the power loss? So first use cable, thick cable, reduce the resistance. Another one is using aluminum. Aluminum also consider low resistance. Why? Because aluminum cheaper and lighter. You need to hang up here, okay? And lastly, step up the voltage to decrease the current. Why? Because when current is small, the power loss is small. All right? Okay. Yeah. Transformer used to increase or decrease the voltage of transformer can only function with the voltage of alternating current. This is the reason why alternating current is used in the transmission. Do you understand? Okay, just like I show you the cable throughout the whole country, right? The whole country, the big cable are all use alternating current one, you know. You know why, you know? Because why only? Because all those transformer only can work on AC. So meaning that the power station must generate current in alternating current. Because only alternating current, you can step up, step down for industry, step down again to light industry, step down again for hospital, step down again for housing area. Only transformer can do, right? And then in order to use a transformer, you must use AC lah. Only use AC. Sir, my one certainly got no sound. No sound already. Ping Yi, are you there?
Yes, sir.
Can hear me or not?
Can. Very clear.
Can hear lah. Chiok the mean not the problem or you cannot hear means is your other people can hear, okay? Other can hear now, okay? Yeah. Okay, so this one finish. So you know already. Okay, now you look at one question. So at least you have to learn answer one question only you can stop. Okay, look at this question. A power station generate 40 kilowatt of electric power using power transmission line with a resistance 8 ohm. This is 8 ohm. Yeah. So what is the power wasted due to the resistance of transmission when the voltage transmitted in 500 watt and then P in 20,000 watt? Okay, let me tell you lah. So I introduced to use, right? The current must be transmitted in high voltage one and all. You see, when transmitted in low voltage are definitely very strong one and it's the power loss. This one transmitted in higher voltage better. You can see the difference. Okay, now let me show you the answer direct. Okay, first you must calculate the current first. Okay, you see now. Use P equal to VI, power 40,000, 40 kilowatt, right? Voltage this one voltage 500, and then you find the current. Okay, why must find the current net? Because to calculate the power loss, you must use P equal to I squared R. So you must know the current. So use this formula to find the current. You see the current so high, 80 ampere. So no good lah. So put it here, you square it. The resistance is 8 ohm, right? So the power loss is 51,200 watt. You see, very thorough. No good. When you transmitted the current in low voltage, the power loss is very high. You see, second one. When the current transmitted in higher voltage, 20 kilowatt, right? You see, you do the calculation. This one voltage 20,000. Then the current so small, the current in the cable. When the current in the cable very small, you see, you calculate the power loss, I squared R, right? You only lost 32 watt. You see, compare 32 watt and this 51,200 watt. You see, this one so much different. This example clearly shows that the transmissions of the power, right, must in high voltage. You see, when you transmitted in high voltage, the power loss so small. When you transmitted in low voltage, you see this one low voltage, See the power loss so big. This one no good lah. See this power loss so small. Understand You understand the concept already, why need to step up. Okay, the reason Okay, copy the answer first. Okay, okay, now I want to ask a little bit question so that I see whether you really understand or not. Okay, now come back to the transmission system, right? Okay. Sinh Yin Chua, Chia Sinh Yin, Xia. Xia Sinh Yin, are you there?
Yes.
Xia Okay,
Ah.
now can you tell me in the transmission system, right? From the power station power station generate the current in how many watt?
25K.
25K, right? Then first place this 25K sent to where? The 25 kilowatt sent to where?
Transformer.
Sent to the transformer. Sent to the transformer for what, Sinh Yin?
Step up.
Step up. Step up to how many?
275K.
275 or?
400.
Or 400 kilowatt, right? Okay, thank you. Very good. Jocelyn, are you there?
Yes, sir.
Jocelyn, now my question is, why need to step up to so high?
To minimize the current.
Very good answer. Why need to minimize it? Why need to minimize the current, Jocelyn?
Because the cable can't withstand the high current.
Yaka, I say that, man. Rianna.
The high current can't go far.
Why the current need to be small? Rianna, can you answer? Rianna? Kaiji, Jiu Kaiji, are you there? Boss, hilang already.
Sir,
okay, Jocelyn, yes.
To prevent the power loss, the energy
yes,
loss.
Correct. And now correct, Jocelyn. Because power loss is I square R. So when the current small, the power loss becomes less, correct not? Okay, I think okay Okay, after this, so the current need to step down. Okay, let me ask one last question before I let you all go. Tai Hoa Khai, are you there? Tai Hoa Khai? Tai Hoa Khai,
Yes, sir.
Tai Hoa Khai, can you tell me in the whole system, how many step up transformer, how many step down transformer using that? How many step up?
One step up.
One step up. Then step down, how many?
4.
How many step down transformer needed for the whole system?
4.
4. 4. At least 4 Okay, at least 4. Yes, correct. Tai Hoa Khai. And Chiu Tong, are you there?
Yes, sir.
Chiu Tong, I want you to tell me the last question. What is National Grid Network?
National Grid
National
Network
is what?
is the whole network for the country.
Yes, it's a network for the country. This network for what one?
For generate and transmit the electric energy.
Connecting all the electric from all the power station in Malaysia, right? Okay, thank you very much, Chiu Tong. Okay, other student got any more question to ask or not? No, I got question or not? No, are you here now?
No.
No, I no question. Mafusa, any question or not?
No, sir.
No, sir. Okay, Okay, 10 o'clock already, So I stop here, So thank you everyone for follow me until here, finish the lesson, All right. So please continue to study every day at home. Continue to study. Okay. I see you next lesson, Bye-bye.
Thank you, teacher.
Thank you, sir.
Bye,
Bye
sir.
bye.
Thanks.
So,
Bye bye. Bye bye.
bye-bye.
Bye bye.
Thank you, sir.
Okay. Bye bye.
Thank you, sir.
Bye, sir.
Okay. Bye bye. Bye bye. Yeah. See you. Huh?